Hello and good morning, everyone. Thank you for coming to this maintainer track session on what's new with etcd, the backbone of Kubernetes, project updates, and new features. So if you're already familiar with etcd or you've been using it and you have been managing it through Kubernetes in your Kubernetes clusters, this is the right place for you. Start it? Oh, no, it's fine. Yep. Okay. So before we start, a little about myself. I'm Arka Saha, a software engineer at VMware by Broadcom. Currently, I'm contributing to the etcd project and also responsible for downstream releases of etcd and Kubernetes. Before I start, I would like to extend my gratitude to all the maintainers and contributors who helped putting up these slides and the content for this session. So before we start, a quick trivia. Who knows from where the name etcd came from or what it means? Anyone? Yep. Yeah. I want to say?
It's a file system. There's a etcd, etc. files. I mean, apart from there is a file structure, server-based things will be in system things. So it came from that one, right?
That's right.
Yeah, thank you.
Yeah, that's on the right. So basically, Linux and Unix has this file system, etc., and there we keep the configuration information data. And D in the etcd is basically distributed systems. So that's how the name etcd came from. So let's look at what we are going to cover in this session. First, we'll get to know about the special interest group for etcd, SIG-etcd, and what's new about it. Next is the very long-awaited etcd operator and how the working group has formed. Then is the feature gates and why we need it in etcd. And finally, the robustness test framework that etcd uses to ensure reliability. Before we jump into the project, let's look at the leadership of etcd. So we have James and Wenji as the SIG chairs, and Marek and Benjamin as the tech leads. So what is this SIG about? So the SIG-etcd owns the etcd project, and it also defines how Kubernetes will use it. In fact, there is an implicit contract between Kubernetes and etcd to clarify the requirements and also improve the testing and the documentation on both the ends. The main goal of this SIG is to provide best production-grade data store for any cloud-native distributed systems. It should be reliable, robust, but yet easy to maintain. And it should be scalable. It should scale for Kubernetes and other distributed systems as well. Like any other projects, we have to deal with regular periodic releases of etcd. And to ensure these releases are production grade, the release process used to take almost a day. But over the years, we have been improving our release process and the release documentation as well. And due to that, the release timeline has gone down from 24 hours to just 20 minutes. In fact, the latest releases of etcd 3.5.17 and 3.4.35 got released a month back in KubeCon NA while being in KubeCon, thanks to James and Ivan for making the releases. And we have also started a release shadow program lately. So you can head over to the issues section in etcd, and there you will see the release issues getting created, and you can volunteer yourself to become a shadow. So let's see about the dev stats. And over the years, we see that there is a constant growth in the contribution from India. And the contributions are around 1,400, not really great, but it's increasing. And that brings us to the third in the ranking of the contributions from India. We can definitely do better than that. And how to do that is basically you can start joining our meetings that happen weekly, and it kind of switches between the community meetings and the bug triage meetings. It happens every Thursday, 11:30 p.m. Indian Standard Time, and these meetings are really good. So these are very focused, and you will be able to get information around the good first issues, the help wanted ones, and also very focused discussions on what kind of debugging and triaging that needs to be done. Currently, due to the daylight savings, this all the times that you see on the screen has been pushed back by 1 hour. So yeah, it's pretty like not very friendly time, but yeah, it's like 12:30 a.m. Indian Standard Time, Friday, very late night. But yeah, these are the good places to start with, and like. Same with the robustness test meetings. So these are again very interactive sessions. And what happens is basically it's a hands-on session where we try to identify the flakes that happen that we see, which I'll be covering again, and also triage these inconsistency issues that might come up in etcd. And the newest thing is the etcd operator meetings that happen again on the same like Tuesday 11:30 p.m. IST. And this is a very good place to start because you will see how the etcd operator is getting built from the ground up. And so feel free to join any of these meetings and get started with your contributions. Again, if you're not able to join any of the meetings, you don't need to worry about it because the documentation that we maintain for each of these meetings, it's very precise, and we actually put down all the things that we discuss, all the agenda and everything you will get to know. So how you need to get to that is you can join one of the Google groups, etcd dev and WG etcd operator, to RSVP to these meetings, as well as you can join the discussions on etcd discussion and join the Slack space for SIG-etcd and WG etcd operator. So any generic questions, any generic doubts, you can post it in SIG-etcd. If you have very specific to some operator, you can post it in WG etcd operator. And all these areas where it needs contribution, you can see all the leads of those areas, like the release team and the operator and the robustness test. So feel free to reach out to any one of them on SIG-etcd channel and get started. So now that we know and we have a fair idea about the SIG itself and the high-level development areas, let's talk about the newest working group, that is the etcd operator working group, and it has been long awaited. So as we already know, the working group is kind of a concept or a construct in Kubernetes governance, where a group of people try to solve a common problem, and they set the goals, non-goals, expectations, and deliverables. And once these are satisfied properly, the group disbands. And in this case, the problem we are trying to solve is a project-supported etcd operator, which was missing for quite some time. So these are the leads of the working groups, and who has started with the development and helped with formation of this group. And so I've been mentioning that it is a long pending, but why do we really need it? So back in 2018, during the CoreOS days, there used to be a repository in CoreOS organization called etcd operator, and it was left unmaintained for quite some time. This led to the fragmentation where all the users of the etcd operator started maintaining their own forks, and either as open source projects or as private internal projects. And they've been doing that. And since etcd has come a long way since then, and we have ironed out most of the issues and all the processes have been streamlined, this is the time when we should start supporting a project-supported operator so that the consumers can depend on it. This is also to reduce the fragmentation in the same cloud native ecosystem that this working group was created. So the goal of this working group is pretty straightforward. We need to design an automated, efficient operator running etcd clusters at scale within Kubernetes. And this working group will discuss the requirements and the use cases of the operator, brainstorm the design, and put together a well-defined roadmap to start the development work. As an immediate goal, we are focusing on developing a etcd operator at the application level, which will run on Kubernetes, rather than managing the etcd clusters, instances running within the Kubernetes cluster for those Kubernetes clusters. And to know and better understand the requirements, we did an extensive survey. And we asked that, okay, how do you run your etcd clusters? And as you can see, most of the users run it as either regular pods or static pods. And there are very less who run it outside of Kubernetes as VMs or containers, and even lesser in bare metal. The next question we asked that, okay, if you run your etcd clusters, what is the scale? What is the number of nodes that you run on? And it's mostly either 100 plus or less than 10. Then we asked that, okay, so now you run your clusters, and how do you manage them? And the majority of the answer was that, okay, there is some in-house operator that the companies and the users maintain to do it. They do it with Helm charts. And there are other tools like kubeadm and etcd-adm with which they also manage it, but mostly it's the operators, in-house operators that we have. And finally, we asked that, okay, what are the pain points in managing these clusters? And very expectedly, it is the member management, followed by the upgrades, backup recovery, and scaling. Although these are very common pain points, the survey helped us to capture these, which were once an assumption, but it has fortified us and helped us to draw a better roadmap. And if you see, this is the roadmap for 0.1.0 release, which is very basic. It's a minimum viable product. And it will ship with the capabilities to create a etcd cluster with a given size and a given version of etcd. It should be able to check the health of the cluster, issue, rotate, and renew the TLS certificate of it. The current plan is to get this release done before the next KubeCon so that people can start using it. And since we are at the very early age of development, it is encouraged to come and join these meetings of etcd operator and brainstorm on the API design. As you can see, right now, it's a very simple API design, a very simple struct consisting of just spec and status. You will find the design doc at the top of the slide in the link. And the spec, again, consists of very minimum requirements, like as defined in the roadmap. It's the size of the cluster, the version of the etcd that will comprise the cluster, and the TLS certificate that will be issued by the issuer. And currently, we are actually working on the TLS certificate and how we can manage it. So basically, the thing is, we will have each certificate tied to each one of the etcd cluster resource. And this etcd cluster name will be prefixed to all these certificates, and it will be mounted as a secret inside each of the etcd pods. So that is the current design decision. It's subject to change as well. But yeah, this is how we are starting it. And yeah, let's quickly go over to the things that we have done as a working group today, where it stands. So we have completed the survey to better understand the requirements and the use cases, and successfully evaluated those results, created the clear roadmap of the requirements and the minimum viable operational operator that we need. We have also successfully created the SIG-etcd owned etcd operator repository, with a basic kube builder scaffolding, that is the scaffolding for any operator. And it is open for development and contributions. So we would want you to collaborate with us. If you're already maintaining an in-house internal project of etcd operator and you're managing your clusters like that, you are more than welcome to come join these meetings, bring your ideas, start contributing, and start brainstorming the efforts. And that's it for the etcd operator. Another exciting news is the feature gates in etcd. As you might already be familiar, that the term feature gates from Kubernetes itself. It's a set of key value pairs. And basically what you do is that you use the feature gate flag to enable or disable it from the CLI. And similarly, you will be able to do this with etcd. Before I start, I would like to give a shout out to the contributors of the feature gates and making it a reality, which we will be seeing in etcd 3.6. So feature gates were always good to have, but the main motivation came from the developer experience with the experimental flags that we maintained in etcd. So what is this experimental flags? So what etcd used to do is that there are many experimental features that we develop, but what we do is that we prepend those features with the name experimental, and once that feature is graduated, we just remove it. Now this causes a lot of breaking changes, and it becomes cumbersome for the developer as well. And there is no way of tracking the status of the feature gate, of the feature. So it is either a graduated feature or it's just experimental. And many a times when the developer is not available and he is not able to work on that feature, it stays in that experimental phase inside the code and maybe forever. This also makes very difficult for the developer because he has to keep a track of this feature, of this experimental flag, across the releases. And wherever he is using it, either in CLI or in his code, he has to make changes to it. So the obvious path becomes in adopting the feature gates style that Kubernetes follows to make our lives easier. And thank you to Benjamin for creating the issue and Siwan for starting and leading the effort. So as a part of this feature gate, we have split the work. So the first part is the server level feature gates, and then the cluster level feature gates. In setting up the framework for the server level feature gates, the respective Kubernetes enhancement proposal has already been raised and merged, which builds the idea on how Kubernetes uses feature gates to port it back to etcd as well. That means each feature now will have alpha, beta, GA, or deprecated flags. Along with that, we want to improve the client-side query for these features. And we will be able to enable and disable this on the fly. And we would also want to migrate all the experimental features that we have to this feature-gated process. And we will be able to see all this in 3.6 release. And the second part is basically the cluster level features, which are essentially a bit more complex, and it targets the underlying data store. And these are those features that needs to be applied to the entire cluster and not just to one node, so to maintain the consistency. So the approach is to leverage Raft in doing so and have a interface query for these features. We should also design a way to remove these feature gates. An important point to note here is that a removed feature gate is different from a deprecated feature. So basically what happens if a feature is deprecated, you will still be able to use it, it's still a valid feature, only that the behavior of that feature will not be affecting your cluster or anything. A removed feature gate is something that is invalid, it is not recognized by the CLI or the system, and it will throw you an error. This KEP is still in progress. It's not yet merged. And you can learn a lot about these KEPs that is going on in the links that is mentioned at the bottom of the slide. And if you find it interesting, please feel free to start contributing and checking out, join the meetings, and yep. So moving on to the final topic of the session is the robustness test that we use to ensure reliability while making etcd releases. Before we deep dive into the robustness test framework, let's look at why we actually need it. Why does traditional integration tests is not enough? As we know, etcd is a very critical component of Kubernetes infrastructure. And like the image shows, if etcd fails, if suddenly it starts giving out wrong information about the cluster, then the entire cluster becomes unstable. And basically, the entire infrastructure will fail. And as we know, etcd itself is a key value store, and it is essential that it should periodically sync uh, so that all the data is available on all, like the same data is available on all the nodes that it comprises of. So whenever there is a query to any one of the node, and they should actually get the same correct value. In an ideal scenario, what happens is it uses raft consensus algorithm to ensure strict serializability and serve the requests of the cluster without breaking any consistency. In one of the rarest scenarios, what happened is the Kubernetes was reporting different pod status for the same pod. And this was due to an inconsistency that was found in etcd. And it is a very serious data inconsistency, as it can render the entire cluster unstable. At that point, it was very hard to reproduce. And whatever existing tools we had, there was no way to reproduce and run it on the upcoming commits and the releases that we had. So we were wondering that how we can fix this problem. And thus we created this test suite robustness test framework, which had basically which had the capability to create these scenarios on demand, inject fail points, and simulate real-life disruptions. In this table, you will see that the issues were discovered and fixed since robustness test framework was implemented. So if you take any one of the issues, you will be able to write an integration test and like for that specific issue with that specific input, but these won't be dynamic. The inputs you won't be able to generate. And that is where this robustness test becomes very special, because it generates a similar pattern and you will be able to reproduce it on the upcoming commits as well. So right now, all these issues are tested against each one of the PRs that you raise in the backend, and that is where we actually track that, okay, is it happening again, whether it is regressing for any of the commits. Now that we know that, okay, what robustness test is and why we need it, let's look at the high-level architecture of it. So it starts with the random input, or what we call it a scenario. What a scenario essentially is, it's a combination of different real-life disruptions that can happen. One of them is traffic pattern. It can be a high-traffic scenario or a low-traffic scenario. Fail points is basically we are injecting and forcing a failure at a certain point of the process. Then is the cluster configuration. So basically, we are telling what kind of cluster it should use, like whether it will be a multi-node cluster or a single-node cluster. What are the versions of those of the etcd with which the cluster should be set up? Again, we can use fail points to imitate a network fluctuation or a network cut between the nodes using the fail points. And once these inputs are done and it is fed into the system, the setup is done, we can capture the data in a JSON format in the form of operation history and watch history, which can further be validated via linearizability checker and watch validator. So if you want to know more about how robustness test framework works, how the scenario that I just discussed looks in code, and how validation is done, what other tools that are used, you can check out this talk we gave 2 months back. And it does a deep dive into this kind of robustness test and how you can implement for your project as well. So far, if you find robustness test and this kind of testing thing interesting, you should start joining the bi-weekly meetings that we have. And this is kind of the dashboard we look at. And we look for any kind of flakes in these. So if you see, these are all the robustness tests that are running, and you will be able to see the names as well. And if there are any kind of flakes or any kind of failures, that's what we investigate. It's a very interactive and hands-on session. And you will be able to learn a lot from this. And this has actually helped us a lot to maintain the code reliably, and all the releases that happen, we know that these issues are not going to come by being able to reproduce it with each commit, each PR that we raise. And that brings us to the end of our session. Thank you for coming, and if you are interested, you keep contributing to it. Thank you. We are open to questions.
Thank you. So I had a question regarding scalability.
Yeah.
So the recommended limit, as far as I know, for etcd is 8 GB, what I've heard of. One of the solutions that we have seen for this is distributing different, for example, Kubernetes native resources like secrets, config maps, we can put in a different etcd cluster.
Yes.
But is there a solution through which we can do for CRDs, which we define? Because I couldn't find a solution for posting certain kind of CRD in a different etcd cluster. So what solutions are we looking for if we're reaching the 8 GB limit and we want to, somehow distribute it? I just wanted to know that, and also if there are any DR use cases that you guys are working on. For example, we have had success with snapshot-based recovery in DR in the past. So that is working seamlessly. So what other improvements also you're looking on in the scalability aspect and DR aspect?
So we have a few issues that has been raised regarding these kind of scenarios, and I think there is some work going on. I'm not completely aware of it, but we can connect offline regarding this.
Yeah, sure. Thank you.
Any other questions?
Hello.
Yeah.
A nice session. Good one.
Thank you.
I've done like more than 100 POCs with etcd. I install etcd on my OpenShift clusters, and my question would be a follow-up with CRD that the first person asked. Like I've experienced a lot of latency issues when I have so many number of CRDs within my etcd cluster. So have you come across any such scenarios, and what was your solution implemented for that? And the second question is, I was very much excited about the adoption that you mentioned in your abstract, the Prowjob adoption. So you didn't speak anything about it, so I thought you can help me with a couple. Yeah.
So yeah, let me start from the back. So yes, the Prowjob Adoption was also a good effort that we started. So as a part of becoming a SIG for Kubernetes, we were required to migrate from the Github Actions to the Prowjobs. So all the Github Actions that we used to run, we are slowly migrating almost everything to as Prowjobs. And I guess right now there might be a very handful jobs that are still running on GitHub, but most of it is on Prow.
Yeah, thanks for that, because I've created my first pro job for HCD implementation last week, so I was
Oh,
excited
that's
to.
great. So you've
Yeah.
already started contributing. Awesome.
Yeah, thanks.
And about the CRD, like exploding of the clusters and whether like the latency issues. Um, I think I saw an issue already. Is there one that you're aware of?
Um, your CPUs go down, you hit very easily when you go more than 10K CRDs for the basic HCD cluster, which starts with 12 gigs. And yeah, there is a latency issue, definitely. I've been using FIO suits to test that, yeah. So I've never understood the solution about it. I kept on debugging.
Yeah, I think there is one latency issue that is open. You should join one of the weekly calls that we have.
Okay.
You can bring it up. If you
Yeah, I've
don't
taken.
see the one that you were mentioning, you can raise an issue yourself,
Okay.
and like someone from like the contributors will be picking it up
Yeah, I'm glad
and
to hear.
working on it.
Thank you.
Yep. You have one. Okay.
So I think on the same line of thought the guy was talking about, so we also face a lot of increase in memory spikes.
Yeah.
So the solution is basically not to read long range queries. You have to minimize the read range queries because etcd internally uses the bold db, which internally uses the mmap, which basically maps the memory of disk to the RAM. So that is the main issue. And one more thing about the person is asking about the 8 GB limit. I think the solution is being done by the Alibaba. I read the blog,
Okay.
but the performance testing has not been done, and that's why the doc has not been updated. But we also haven't done the performance testing. And one of guy from our team interacted with Marek in KubeCom NA, and I think there were some discussion about we will do the performance testing and maybe update the etcd to increase the limit of from 8 GB to something more. But yeah, we are also not sure.
Yeah, maybe we can see that in 3.6. I'm not sure about it, but yeah, that's good information.
Yeah, thank you.
Thank you.
We done for time, or is there time for another
Yeah,
question?
I think we are almost time. Do you have? We can take one last question. You also have one?
Limitation issue, especially for CRD. If you guys are using not a dynamic CRD, I mean, in case if it is a fixed CRDs for organization, then I would suggest to go with aggregation API server. By that way, you will overcome this issue. So if you have aggregated API server, then you can override the based on your APIs for HCD. It's similar to the how Kubernetes service is doing for existing inbuilt APIs. So by that way, we can overcome the CRD issue for limiting ourselves with the 8 GB. Yeah.
We will connect offline. Yeah. Okay. Thank you so much.